Hello, and welcome to this short demonstration of Wind River Hypervisor and Wind River Workbench on-chip debugging. My name is Mark Hermeling, and I'm a Senior Product Manager working at Wind River, specifically focusing on multi-core and virtualization. In this demonstration, I want to show you a few options of how to debug a multi-core system. Say I have a system such as a Freescale 8572 depicted here, which is a dual-core system. On top of these dual cores, I run my Wind River Hypervisor, which provides partitioning capabilities. And on top of that hypervisor, I can create multiple different virtual boards. And in this particular demo, I'll use one Linux virtual board. I'll use a VxWorks virtual board as well, and I could run a virtual board application in VBA too if I wanted to. The VBA virtual board is a bit special because it doesn't utilize an operating system, and it's really useful to do algorithmic offload capabilities, for example. Now, there's two main solutions that people use when they start debugging. And one solution is called agent-based solution, and there's other videos available on YouTube that I've made that show you how you can start debugging multi-core systems using agents. And basically what you do is you run a software piece inside of the operating system, and then your debugger connects to that software piece and gathers the information about the operating system and feeds it back to the debugger. Works really well, but for it to work, you have to bring the operating system up and some form of communication layer with the debugger, say serial or Ethernet, and it's really limited in scope to that one operating system. And besides that, you cannot use it to debug your virtual board application. Your virtual board application doesn't have an agent. So the other solution that I want to talk about today is called on-chip debugging. And what we do is we take an in-circuit emulator, an ICE, and what you see here is a picture of a Wind River ICE. It's an ICE 2 actually. And you connect that ICE directly to your physical chip. The chip has a debug port, the ICE connects to the debug port, and your debugger itself on your host workstation connects to the ICE. And that allows you to start inspecting, stopping the processor, inspecting registers, inspecting memory, and all those type of debug type of actions from the moment that the chip turns on. So you can actually debug operating system bring up, you can debug the entire system as well, meaning I can put a breakpoint in Linux, and when that breakpoint is hit, stop my VxWorks partition as well. So on-chip debugging provides you with a lot more options. And there's typically 4 different areas that people use on-chip debugging for. As I mentioned, hardware bring-up, also development of kernels or devices. If you do a lot of device development, the on-chip debugger will really help you debug those devices during the boot-up process and during interrupt handling and things like that. The third case is system integration. If you're in system integration of a large software system, you typically don't want to add more software to the system. You found a bug, there's something where the system doesn't properly behave, and the last thing you want to do is add more software to it. So the on-chip debugger will allow you to debug that system in its environment with all the test harnesses attached, and you don't have to add more software. And then the last case is to do automated device testing once your device is ready and things like that. So Wind River, of course, has on-chip debugging solutions. They all use the same Wind River IDE, so it's all driven by Workbench, which is the same IDE that you use when you build your software and develop your software. So it's really easy. Your developers are instantly familiar with it.